11.4 compound events. I can find the probability of compound events.
And Samaya, thank you. What does the word compound mean?
More than one.
Samaya.
2 or more things.
2 or more things or more than one thing. So, perfect. Sample space. We talked about this a couple times now. It's a list of all of the possible outcomes. Tree diagrams we're going to see in a bit. Fundamental counting principle, we abbreviated to FCP. The fundamental counting principle is a formula. It's on your cheat hole. It's M times N. Hey, Mr. Justic. Everybody, what does M represent?
The first set of outcomes.
What does N represent?
The second set of outcomes.
Could there be a third, a fourth, or a fifth set of outcomes?
Yes.
So this M times N could go on. And we actually will show that here in a second. When you compare the fundamental counting principle to the tree diagram, you are looking at basically the same thing, but different ways of reporting it out. So in our number 6 question, we said, how many possible outcomes are there in flipping a coin 3 times? So when you flip a coin once, how many outcomes are there?
2.
When you flip a coin a second time, how many outcomes are there?
2.
And when you flip a coin a third time, how many outcomes are there?
2.
And if you multiply all of them together, because we did the first outcome by the second outcome by the third outcome, 2 times 2 times 2 is 8. But if we wanted to know exactly what those outcomes are, we would make a
Tree diagram.
and a tree diagram really shows the what?
Sample space.
This is the sample space. It shows literally what all 8 of these right here are right here. Because are there 8 of these here in the tree diagram column? Yes, and we listed them all out. And the way you make a tree diagram is you list all of the possibilities for your first event, all the possibilities for your second event, and all the possibilities for your third event, and you link them together. Yes, no?
Yes.
It's more realistic down here at Andrew's Restaurant. I think this will probably help you the most. Andrew's Restaurant offers appetizers, entrees, and desserts. 2 appetizers, 3 entrees, and 2 desserts. If I simply want to know the number of possible possible menu items, I would use what?
FCP.
That wasn't everyone. I would use what?
FCP.
Because there are 2 appetizers, and there are 3 entrees, and there are 2 desserts, I just multiply them together and there are 12, right?
Yes.
But Andrew actually needs to print menus for his restaurant, yes, no?
Yes.
And so he needs to know what to put on the menu, so he remembers way back to 6th grade when he had Mr. Pottinger, and he's like, oh yeah, I'm going to make a tree diagram. And I know that my first option would be nacho and cheese sticks, so someone has to choose nacho or cheese sticks, right? And then the second option would be fish, steak, or chicken, yes, no?
Yes.
Fish, steak, or chicken, yes, no?
Yes.
Yes. And then the last option is dessert, the best part of a meal. If someone chooses nachos and fish, they have to choose either ice cream or pie. So this ice cream and this pie would be 2 of our options, right? If they choose steak, they still need to choose ice cream or pie, right?
Yes.
So there's 2 more options. If they chose chicken and nachos, they still need to choose ice cream or pie, and there's 2 more options, right?
Yes.
So if we add up all of the options together, we end up with 12 total options. Yes, no?
Yes.
And the last thing we did is we calculated the probability of what people would order at the restaurant. Probability of fish, well, fish takes place on the menu 3 or 4 times, so there's a 33% chance someone will order fish. This is where it got a little trickier. What is the probability of someone ordering steak or chicken? If you look at your sample space, if steak is in there, it counts. If chicken is in there, I'm sorry, steak or ice cream. Did I say chicken?
Yes.
What is the probability of someone choosing steak or ice cream? If steak is in the sample space, it counts. If ice cream is in the sample space, it counts, right? Do they have to be together?
No.
No, because the word or means they can be separated, right?
Yes.
But if you want to know steak and chicken, do they have to be together? I keep saying chicken. Steak and ice cream, do they have to be together?
Yes.
And we only found steak and ice cream together 2 out of
12.
questions. Sedona.
Can a tree diagram be like flipped on its side?
It can be flipped on its side. So when I did my tree diagram on the wake up a couple weeks ago, I purposely, I actually think I did it this way, the sideways, but you can do it, have it going up and down too, if that works better for you. I think Luke did it that way in his notes, right, Luke? Okay.